Today we will explore the basics of thermodynamics. Thermodynamics is the branch of physics that deals with the relationships between heat, energy, and work. It's a fundamental theory that governs many natural processes and technological applications, from engines to refrigerators to the behavior of stars. At its core, thermodynamics is based on a few key concepts. System. This refers to the specific portion of the universe that we're interested in studying. It could be anything from a cup of coffee to an entire galaxy. State. The state of a system is defined by its properties, such as temperature, pressure, volume, and composition. These properties can change over time due to interactions with the surroundings. Process. A process is any change that occurs in a system, such as heating, cooling, expansion, or compression. Thermodynamics describes how energy and matter flow into, out of, and within systems during processes. Equilibrium. When a system reaches equilibrium, its properties no longer change with time. This could be thermal equilibrium, same temperature throughout. Mechanical equilibrium, no net force, or chemical equilibrium, no further reaction occurs. Laws of thermodynamics. There are 4 laws of thermodynamics, but the first 3 are the most fundamental. First law, also known as the law of energy conservation, it states that energy cannot be created or destroyed, only converted from one form to another. In other words, the total energy of an isolated system remains constant. Second law. This law deals with the concept of entropy, which is a measure of the disorder or randomness of a system. It states that in any energy exchange, if no energy enters or leaves the system, the potential energy of the state will always be less than that of the initial state. Put simply, natural processes tend to move towards states with higher entropy. Third law. This law states that as the temperature of a system approaches absolute zero, Kelvin or 273 C, the entropy of the system approaches a minimum value. It's often phrased as, the entropy of a perfect crystal at absolute zero is exactly equal to zero. Thermodynamic processes. These are ways in which a system can change from one state to another. Common types include isothermal, constant temperature, adiabatic, no heat transfer, isobaric, constant pressure, and isochoric, constant volume processes. Heat and work. Heat is energy transferred between systems due to temperature differences. Work is energy transferred by a force acting through a distance. Both heat and work are forms of energy transfer that can change the state of a system. Thermodynamics provides a framework for understanding and predicting the behavior of systems in terms of these fundamental principles, and it has countless applications across physics, chemistry, engineering, and beyond.